In this video, we're going to solve some sine and cosine rule problems. A passenger that's travelling due north on a straight piece of road finds that the bearing of a factory is north 24 degrees to the west. After travelling a further 2 kilometres, the passenger finds that the bearing of the factory has become north 68 degrees west. We need to find the closest distance that the factory is from the road. Now the closest distance is achieved when the road makes a right angle with the line to the factory like this. Let's label the diagram for reference: A, B, C and F for factory. The distance that we're trying to find is in a triangle that we don't know too much about. So we're going to look to the other triangle, ABF. Now we know a lot more about that triangle and we can use it to determine distance BF. Let's call that distance X. Once we find out X, we're going to be able to go back and look at that small triangle and we'll have enough information to find out distance D. So, looking at the large triangle, it's a good idea to write down everything that we know about it. We know, for example, that this angle here is 112 degrees because it goes with 68 degrees to make up the 180 degrees in a straight line. We also know that the only other angle in this triangle must be 44 degrees because the angle sum in a triangle also adds up to 180 degrees. It's time to redraw the triangle and see if we can find out what X is. Now there's enough information here to use the sine rule. X over the sine of the angle opposite it, 24 degrees, is equal to 2 over the sine of the angle opposite it, 44 degrees. Multiply both sides by the sine of 24 degrees and use the calculator to find out X. Now we can look at the small triangle, BCF, and use right-angled triangle trigonometry to find out the distance D. We know the distance X equals 1.171 kilometres, and this question involves opposite and hypotenuse. It's a simple sine question. Sine of 68 equals opposite D over hypotenuse 1.171. We just have to transpose and use our calculator to evaluate D. D is equal to 1.09 kilometres. Let's have a look at another problem. A fishing dinghy leaves a jetty and travels 3 kilometres to a fishing spot on bearing 150 degrees true. While fishing at this spot, the dinghy drifts 5 kilometres on a bearing of 222 degrees true. We need to find the distance and bearing of the jetty from the dinghy. In order to work these out, we need to know more information about this triangle, in particular angles inside this triangle. If we could work out this angle here, we would be in a strong position to work out D using the cosine rule. Now that angle is made up of two parts, and the bottom part of it must be 48 degrees, because 48 degrees goes with the bearing of 222 degrees to make 3/4 of a circle, or 270 degrees. The upper part of the angle we can work out because the two red angles are equal. Those angles form the Z. They're what we called alternate angles, and they must be equal. They must both be equal to 60 degrees, because 60 degrees goes with 90 degrees up at the top there to form the bearing of 150 degrees. Now we know enough about this triangle here to redraw it and use the cosine rule to work out the distance D. D squared is going to equal the sum of the other two sides squared minus twice their product times the cosine of the angle in between them. So it's the cosine of 108 degrees. Work it out and take the square root and we'll come up with the distance D is equal to 6.578 kilometres. Now we were also asked to work out the bearing of the jetty from the dinghy. So we place in a fresh compass rose at the dinghy, and it's that little red angle in there that's going to give us the bearing required. Once again, it's an angle which is not inside the triangle that we're working with. So we're going to work out this angle here, call it A, first, and then we'll use it to work out the bearing. We now know quite a bit of information about our triangle. We know that D equals 6.578, so we can use the other form of the cosine rule to find out angle A. Set it up and then carefully solve it. Remember the tip of doing the top line and the bottom line separately in these circumstances to save you from error. Should come up with A equals 25.704 degrees. To determine the bearing, we're going to need to find this blue angle here. But that's going to have to equal 48 degrees because it's an alternate angle. It forms the Z with the angle that we determined earlier. Now we can determine the bearing because the three angles together make up 90 degrees. Make sure that you write your final answer in degrees and minutes.